Hey everyone, and welcome to this explainer. Look, if you're gearing up for the CDS exam, you already know the deal. The math syllabus can honestly feel like this massive, impenetrable wall just standing between you and your goals. But today, we are going to take that dense, intimidating syllabus and transform it into a crystal clear, visual roadmap. By the time we wrap up here, you are going to have a perfectly structured game plan to totally ace this exam.
Okay, so let's just jump right in. When you first glance at the raw syllabus document, it is incredibly overwhelming, right? It's super text-heavy, incredibly dense, and honestly, it's so easy to look at those endless bullet points and just start to panic. But don't worry, we are definitely not going to just memorize a giant wall of text today. We're going to decode it together.
And we're going to de-stress this whole process by breaking all that text down into exactly 6 manageable mathematical realms: arithmetic, algebra, trigonometry, geometry, mensuration, and finally, statistics.
Let's kick things off with the absolute building blocks of your journey. Realm number 1, arithmetic, the foundation.
What's really brilliant about how the syllabus handles this is that it splits arithmetic into 2 distinct buckets. First, you've got the highly practical number system. This is your everyday math, things like time, distance, percentages, profit and loss. Then you shift into the structural mechanics with elementary number theory, where you'll be diving into prime numbers, divisibility tests, and factors.
Now, within that number theory section, you kind of have to go beyond just the basics. You must specifically master core algorithms, like the division and Euclidean algorithms. You've got to be rock solid on the factorization theorem, HCF, and LCM. And this is crucial. The section explicitly demands that you conquer logarithms to base 10. Literally, knowing your log tables and laws is going to save you so much time on test day.
All that foundational math builds directly into our second realm, algebra, equations, and polynomials.
This is where we shift away from purely known numbers and start hunting for the unknown, which introduces a whole new level of abstraction. The heavy lifting here is going to come with the remainder theorem and polynomial theory. But hey, pay really close attention to the fine print here. While you need to understand the relationship between roots and coefficients, the syllabus strictly limits this to real roots. So seriously, don't waste your time studying complex roots for this section. But you aren't just, moving letters and numbers around algebraically. When it comes to simultaneous linear equations with 2 unknowns, the syllabus explicitly requires you to grasp both the analytical solutions and the graphical solutions. You need to know how to solve it on paper with standard equations, and then be able to visualize exactly what that solution looks like when it's plotted out on a graph.
Because algebra isn't just pure theory for this exam, it is heavily applied. The test makers want to see if you can take a messy, real-world word problem, translate it into a clean equation or inequality, and solve it. You'll round out your algebra toolkit by mastering set notation, rational expressions, and conditional identities.
Okay, so now that we've conquered that abstract world of algebra and confidently solved for x, we have to ask a totally new question. How do we take these numbers and equations and actually apply them to physical space and the real world around us?
And that question leads us perfectly into our third realm, trigonometry, angles and distances.
The syllabus is incredibly specific and honestly very helpful, here drawing a clear boundary around what you actually need to study. Your primary focus should be locked onto sine, cosine, and tan, specifically constrained to angles between 0 and 90 degrees. You don't need to stress over complex, massive angles. You do, however, absolutely need to have the exact values memorized for 0, 30, 45, 60, and 90 degrees. No exceptions.
Once you have those locked in, you'll take those specific angles and put them to work. The exam is going to test your knowledge of simple trigonometric identities, your ability to read trig tables, and, this is a big one, your ability to solve practical cases involving heights and distances. Think of a scenario where you have to figure out the height of a building based on an angle of elevation from the ground. That is exactly the kind of thing they are looking for here.
So where trigonometry focused really heavily on specific angles, our fourth realm, geometry, broadens the scope entirely. Lines, shapes, and theorems.
Geometry is highly theoretical. You are going to be proving relationships left and right. You'll start with parallel lines, and then you're going to spend a massive amount of your time on triangles, analyzing their sides and angles, proving congruence and similarity, and understanding exactly where their medians and altitudes intersect.
Moving beyond triangles, you'll need to know the properties, specifically focusing on the sides, angles, and diagonals of basic quadrilaterals, like rectangles, parallelograms, and squares.
You've also got to master circles, which explicitly includes understanding tangents and normals. And finally, this section throws in the concept of loci, which is basically tracing the path of a point under very specific given conditions.
Now, we just discussed geometry and all those shapes and theorems, but how is that different from our fifth realm, mensuration, calculating space?
It's a great question, actually. While geometry is all about theoretical properties, proofs, and the relationships between lines and angles, mensuration is just the pure, hard calculation of space. It's about taking those 2D shapes we just talked about, parallelograms, squares, rectangles, triangles, circles, and finding their exact numerical area. It's also about calculating the physical surface area and the volume of 3D figures.
You'll want to pay special attention to the explicit mention of the fieldbook method in the syllabus. This is a highly practical skill. The exam isn't just going to hand you a perfect square and ask for the area. You need to know how to logically take a complex, totally irregular area and split it up into simpler, basic figures to calculate the total measurement.
And when it comes to 3D objects, all the guesswork is removed. Your target list is super strict. You must master calculating the lateral surface and volume for right circular cones and cylinders, and you have to know how to calculate the total surface area and volume for cuboids and spheres. Truly, if you have those specific formulas memorized and know exactly how to apply them, you own this section.
Finally, we've reached our ultimate destination, realm number 6, statistics, data representation.
This is where traditional math meets the modern world of data. Statistics here is largely about visual communication. You need to be entirely comfortable reading, creating, and interpreting things like bar charts, histograms, and frequency polygons to understand exactly what a dataset is trying to tell you at a glance.
Once all that data is tabulated, say into a pie chart or a table, you have to find the signal in the noise. That means getting really comfortable calculating the basic measures of central tendency. Quickly finding the mean, median, and mode to accurately summarize massive sets of information.
And there you have it. What started as a terrifying wall of text is actually a highly organized, 6-part strategic journey. You now hold the decoded roadmap to the entire CDS math syllabus right in your hands. You know the exact tactics required for arithmetic, algebra, trigonometry, geometry, mensuration, and statistics. The only question left for you is which of these 6 realms are you going to choose to conquer first today? Pick your battleground, dive right in, and start building your mastery. Good luck.